Hey everybody, this is part 2 of the frequently asked questions. The next question that I got was, could you go over how to do cross products both 2D and 3D? One bit of clarification here, there is no such thing as a cross product in the two-dimensional plane. There just aren't cross products in any setting except for three-dimensional space. And the reason for that is interesting if you look at it geometrically. The reason is, if I have two vectors in three-dimensional space, let's say the directions that my arms are pointing. Now I'm trying to point horizontally, and it looks funny because my webcam is pointed at an angle, but assume that I'm pointing horizontally. Okay, that means that the cross product of these two vectors is going to be either straight up or straight down vertically. That's because that's perpendicular to both of these directions. Now suppose you try to do this sort of geometry in the plane. I gave you two vectors in the plane. And I ask you to find a vector that is perpendicular to both of those. Well, when you think about it, there's no way you could do it except to choose a direction that's outside of the plane. So in two dimensions, you simply can't find a direction that's perpendicular to both of these. So the cross product as a geometric concept doesn't exist in the two-dimensional plane, nor does it exist in four-dimensional space, because if I give you two vectors, there are actually many directions that are perpendicular to both of those in four-dimensional space. So it turns out 3D is just right for finding cross products. Now, I don't think that was the question that you were asking. The question was, how do you find them computationally? And I'm going to demonstrate a couple of methods for doing that I've seen, a couple of my favorites. You can choose which one is most comfortable for you. But let's suppose that V is equal to 2i minus 3j plus k, and W is equal to 3i. Actually, let's make these the same as before, so that's a 3j. Sorry about that. 3i minus 4j plus k. I think those are the same as I had written down earlier. It doesn't matter terribly. I just like to be consistent. All right, one way of finding V cross W is to write down the following matrix. This is a 3 by 3 matrix. The first three entries on the first row are I, j, and k. And then on the second and third rows, I put the components of V and W. The components of V are 2, 3, 1, and of W they are 3, -4, 1. So I have a 3 by 3 matrix, and you'll notice that there are vertical bars around it. That means I'm going to take the determinant of this matrix. Okay? In order to take the determinant of this matrix, here's what I'm going to do. I'm going to add a couple of columns to the right side of the board. The first column that I'm going to add is a copy of the first column. So here I have I, 2, 3. I'm going to put another copy of that outside. Okay, and the next thing I'm going to do is copy the second column, j, 3, -4. All right, and at this point I'm just going to check my video to make sure that this is still visible. Okay, I think that it is barely, so I'm going to keep going. Okay, now pay careful attention to the next step. I'm going to draw 3 diagonals. 1, 2, and 3. And I very deliberately drew those slowly so that you can see what I was doing, because I know that the red is hard to see. I'm going to multiply the entries along each diagonal. Along the first diagonal, I have 3 times 1 times I. That's 3i. So V cross W is going to start with 3 times 1 times I. That's 3i. And then I'm going to add 1 times 3 times j. That's 3j. And finally, I add 2 times -4 times k. That's a -8k that I'm adding. So minus 8k. Okay, this process is so nice I have to do it twice. So I'm going to draw 3 more diagonals. This one, and this one. The next step is to subtract the product along each of these 3 green diagonals. Along the first diagonal, I have 3 times 3 times k, that's 9k, which I am going to subtract. I'm subtracting 9k. My next diagonal is 1 times negative 4 times I, that's negative 4i. If I subtract negative 4i, that's the same as adding 4i. And finally, 2 times 1 times j is 2j, so I subtract 2j. So now I have a lot of components written down. This can be simplified to 3i plus 4i is 7i. 3j minus 2j is plus j. And minus 8k minus 9k is minus 17k. All right, so my cross product should be 7i plus j minus 17k. I know that's probably barely visible. I apologize for that. I'll try to put a caption in. But now that I've calculated this, now that we're here, how do I know whether I got it right? Is there a way of checking whether it's right? Well, you'll recall I said in the previous video that the cross product is supposed to be perpendicular to both of the vectors that I'm taking the cross product of, v and w. And we have a quick way of checking whether things are perpendicular, because two vectors are perpendicular if and only if their dot product is 0. So I can dot this with each of my two vectors and see if I get 0. If I dot this with v, I get 7 times 2 is 14, plus 3 times 1, that's 17, and then minus 17 times 1, that's 17 minus 17 is 0. You can check it with the other one to make sure. I usually feel pretty secure after I've checked perpendicularity for one of the vectors, because if I made a silly sign error, it's probably going to show up in both of those calculations. So that's one method. This is a method that I know that many instructors are pretty fond of. I like showing this one, and this is the one I usually use when I'm trying to find the cross product. There is another way. I'm going to draw the same matrix again to start out. V cross W is equal to the determinant of this matrix Okay, what I'm about to do is a technique called expanding by minors, M-I-N-O-R-S. This is the minors method for finding the determinant. The way that I do this is I start by looking at the I. I know that this vector is going to have some I component, and what the I component is going to be determined by the 2 by 2 matrix that is not in the same row or column as the I. That's this matrix right here. 3, 1, negative 4, 1. These 4 entries here. The determinant of that matrix tells me what the coefficient of I should be. I'm going to write that down. So the first part of V cross W is determinant 3, 1, negative 4, 1, I. For J, I'm going to take the determinant of the matrix 2, 1, 3, 1. Again, I'm taking all of the entries that are not in the same row or column as J. Now, the funny thing about this is I have to subtract the result of taking this determinant. And the reason is that in general, when I compute a determinant by minors, I have to alternate the signs when I go through the process of writing down all the minors. The reason that you do that, alternate the signs, comes from linear algebra, and I don't have time to go into it here. But you'll learn about that if you take Math 215. Okay, and finally for K, I need the determinant of, notice I'm adding this time because I'm alternating the signs positive, negative, positive. I need the determinant 2, 3, 3, negative 4, K. Now, to calculate these 2 by 2 determinants, I simply multiply this way, and subtract the two products that I get. So I'm going to do 3 times 1 is 3, minus 1 times negative 4 is negative 4. 3 minus negative 4 is 7. 7i. For this one I have 2 times 1 is 2, 1 times 3 is 3, 2 minus 3 is negative 1, but I'm subtracting, so that's a plus j, which I believe is consistent with what I got before. And for k, I have 2 times negative 4 is negative 8. 3 times 3 is 9. Negative 8 minus 9 is negative 17. So I have a minus 17k. It should be the same as what I got before. That's negative 17 certainly sounds familiar. So that's the other method. I actually use this one sometimes to compute cross products in my head. I'll just look at this, stare at this, and go, okay, for I have 3, 1, 1, negative 4, 3 minus negative 4, 7, 7i, and then jot that down, and then do the same for j and k, keeping in mind when I need to subtract the result of the determinant for this matrix here. Okay, don't try doing these in your head until you are super comfortable with this. Use a method that you can write down that prevents you from making errors more than necessary. My suggestion is find the method for you that is the most error-proof, and that'll depend on your personality. Okay, that's my video on how to compute cross products. Next, we'll talk about projections.